Thank you. Yeah, I was listening to the previous talk. I was struck by how totally different my talk's going to be. And maybe that goes to the balance here, sort of the artistic and humanistic aspects, and then the technology underneath the hood. And I'm also going to get in trouble because in my title is the word game, right? So Dan's going to give me a hard time about that. That's why I say fits for games, or you can broadly define it for interactive media also. So if I was unsure what technology to talk about, so I figured if I got it wrong, you just have to invite me back for another talk to get it right the second time. So first I thought I would show sort of a clip of a few games here. This one's not started. But not too important. So a bit, you know, as you see the visual, artistic aspects up front, you can, observe the different styles here, the different kinds of games. What I want to talk about is the technology a bit under the hood. So we start at the top left corner. Do you know what that game that is? Who knows what that game is? Any guesses? What is that? Shout it out if you know it.
I forget the name.
Japan Rumble Box is the name. It was in the Game Festival, one of the awards for best games. So simple artistic style, a lot of subtle things going on there. They're knocking these blocks off, they fall on the ground, the avatar can then climb on top of them, he's trying to escape from this box. Moving over to the top right, very different artistic style. I mean, you know what game that is? Which one's that? Yeah, Facade, right? And it has a sophisticated, called artificial intelligence broadly, so sophisticated interaction with the avatars. You role play the friend of this couple that's having marital troubles, and you either can force them to get a divorce and storm out, or you can help them get together, depending on what you want to do, and concentrating on that aspect of it. Bottom left here, who can guess that game? Okay. This was a game, it's the game Fahrenheit, anybody knows that, or Indigo Prophecy. So, 3D game, you move around it. The technology concentrating on interactive storytelling, so interactive narrative, where most storytelling is linear. In this case, the protagonist, the player, can actually influence the story, the way it unfolds. So that's that game. Bottom right. Anybody know this game? Game at the bottom right. Any guesses? One of the Lord of the Rings games. Yeah, Lord of the Rings 2, Battle for Middle-earth 2, Expansion said Rise of the Witch King. So version 2.0. No, I'm just kidding. So this game, right? So lots of units moving around. 3D is a combat game. Lots of things happening. You have sophisticated unit movement. Lots of behaviors that are happening. Very balanced gameplay. It also does online. So you play this with other people online. Lots of people at once. Okay, so this is just one sampling of games you might have. And so you kind of take a look at all the games you might imagine building, and interactive media applications in general if you want to. And so sort of the part that maybe you got a taste of is some of the technology that has to go under the hood to make them happen. Right? So we have artistic stuff. I'm not talking about that. I'm talking about the computer science angle, if you will. So it's a lot of code, if you want. Software engineering. You have to design it, build it, test it, maintain it. Other aspects include human-computer interaction, making that interface work right, computer architectures, databases for that persistent storage of the world, graphics and animation, artificial intelligence, and then computer networks. And so computer networks is sort of my specialty, and so that's a very brief, broad look. What I'm going to talk about next is sort of one topic inside computer networks. I was told to talk about something I think is cool. I think this is pretty cool. So I'm going to talk about latency in computer networks, and that's the rest of my talk. And so what is it? How does it matter? How much does it matter? And then what can we do about it? So a bit of the tech here is what I'm hoping to do. Okay, so latency. So what is it? So you typically have a game client, so it's playing a game, and traditionally, in all sort of commercial aspects, nearly all of them connect to a server. Right? And so you take input, you mash on the key, click your mouse. That input has to be packaged up and travel through this big network cloud. Network people like clouds. This big cloud, fly around, makes it to the server. Latency is the time between when you start it and it reaches the server. You often also care about the response from the server. So you send something to the server, it says, okay, sends it back. So that's the round trip time. So one-way latency is time to get there, round trip time to come back. All right, so that's in a nutshell, that's what latency is. So why does it matter for the things we're doing online? Well, this is that same picture. I got my client on the left, I got my server on the right. This is now a timeline going down. So again, the model here is the server keeps track of the game world. It holds all the objects, it keeps track of where everything is, and the clients then take input from the users, and the server has to decide if that input, how it affects the world. So you package up a message, you send it like, hey, I'm swinging my sword, or I'm moving left, or I'm talking to this person, and that's the message that goes to the server. The server says, okay, you can do that, or not, depending on what the server says, responds back to the client. So the time that you say, hit your button, click your mouse, type your words, and package it up and send it to the time that you actually can then render that input so that it can be effective on the client, you can see it. That's the response time. So the higher the latency, the less responsive the application is. Right? So that's kind of a high-level view. If you have high network latency, your application is less responsive. And so a bunch of ways you can show it. This is one of my undergrad students did this. He was playing Madden NFL, and he did some latency experiments with this. And so here's an example. Ricky Williams, you can tell this is an old version of Madden NFL, where he's no longer for the team or in the NFL for that matter. So right, he's running left, and the user's pressing left. Right now in this sample, you set up client server. He added an artificial amount of latency, 500 milliseconds in between. And so in this play, you can see the defender there has fallen down. So normally Ricky Williams, really fast turn upfield, make a big gain. He's not going to be able to do that because he goes, okay, go up, right? So he's telling the server, I'm going to start running down the field, break down the sidelines. But because of the latency, the application is not responsive, and sure enough, it goes out of bounds, and the player gets mad, right? So latency has impacted the gameplay here. And so kind of one example of how you might see it. You can think of many other ones. Okay, so that's one way latency matters, responsiveness. So you can imagine there's other things you can do that are a little more sophisticated. In particular, most game clients don't really wait entirely for the server to say okay or no. So what they do is they say, well, I'm going to do this command, and I assume the server is going to say go ahead and do it. Right? So they say move up the field. And right away, rather than waiting for the server, I'll go ahead and actually make it so the avatar, whatever it's going to do, is going to move. I'll still have to send that information to the server, because the server, again, is going to still be the master, going to keep all the game state, it's going to say, yeah, that's okay. And so that message still has to go back and forth. But what I can do here is I can actually start rendering the inputs, I can actually start changing the world locally, and it makes it look very responsive. Right? That response time part is really small. So I made it so my application is responsive. Now this, though, has another downside. Notably, that since I've started changing the world over here, the view on the client of the world is different than the view on the server. Right? So there's an inconsistency there. They view the world differently. And the larger the latency, the more time has elapsed between messages flying back and forth, the more inconsistent they will be. So latency can also affect the consistency of game world from client to server and across clients. So another example, same game, going with the same theme. So again, we have we have client server hooked up, two PlayStations hooked up with a TV. This is a picture-in-picture, so we can actually see it both. Right? So in this play, the client now has said, put my wide receiver in motion. So for football, it's American football, right? Not soccer. So football, the receiver is going to go this way across the screen. He's going in motion behind the receiver. That's that box character. That picture-in-picture, the small one, hard to see, but that's the server's view. And there's 500 milliseconds of latency, so the package is still flying over there. So it has not started changing the world state. So the server's view, exact same point in time, has the receiver further back. There's an inconsistency there. And what will happen is when the message comes back, you have to resolve that inconsistency at some points. And when you do, there's smooth ways to do it, and some are easy, and some are hard. So the inconsistent state problem causes issues. So this example of how you might see inconsistency. So latency affects responsiveness, it affects consistency. The third thing is take the world and expand it to multiple players. Right? So you have a game server again, you have two clients. And now let's say the clients have different latencies to the server. There's one that's close and one that's far away. Right? So in the middle here, the client on the left is closer, sort of depicted closer, and the one on the right is further away. So the one on the right is closer, the one on the left is further away. Right? So the server, let's say they're battling a monster. They defeat the monster, the server says, here's some treasure, generates a treasure message, sends that to both the clients. Right? So that's the messages flying to the clients. It gets to the client on your right first, the one that's closer. So that player says, aha, there's treasure. Tells Avatar to act upon it, get that treasure. Right? And so it gets the treasure, the server says, okay, you got it. Meanwhile, the message has been flying around the internet cloud. It arrives at the client over here on this left side later, because it's further away, latency's higher. And then the player says, get that treasure. And it tells the server to get the treasure, the server says, tough luck, it's already gone. Right? So the fact that the latencies are different, and one's higher than the other, affects fairness. Notably, the one that's closer, the client that's closer, will have an advantage in this sort of simple scenario. Right? So responsiveness, consistency, and fairness.